Here's a video discussing section 3.4 part 2 on solving log functions. So here we have e to the 2x minus 4 times e to the x plus 3 equals 0. What you're going to want to do, because these are pretty tricky to solve, is let any variable, you can use a, b, c, d, whatever you like, equal the middle term, which of course is e to the x. So we're letting this equal a. So naturally, this would mean that if I square both sides, a squared would be e to the x squared, which of course is e2x using properties of exponents. So this enables me to convert this equation to a quadratic equation. So instead of e to 2x minus instead of e to 2x minus 4 times e to the x plus 3 equals 0, I can make it a squared minus 4a plus 3 equals 0. And then I treat like a quadratic. So I do a little factoring. A minus 1, a minus 3 equals 0. So a equals either 1 or 3. Awesome. However, we're not asked to solve for a. We made up a. We were asked to solve for x. So this means that e to the x equals 1 or e to the x equals 3. Hopefully you can see that e to the x equals 1, x is 0, because anything to the 0 power is always 1. But in this case, I probably want to rewrite as a log. Log base e of 3 equals x, which is really just ln 3 equals x. And if you use a calculator, get my calculator out here, I should get ln 3 is 1.099. That's roughly what x equals. And so either one of those two answers would work. So again, the strategy here is to make up a variable, let it equal e to the x, and even if you don't see e to the x, let's say you see 2 to the x or 3 to the x, fine. Let a equal that, and then the term that has 2x as an exponent, make that a squared, and treat it like a quadratic. And then you kind of just check it out near the end here. And remember the property that we used over here. If I change colors, blue. Remember we've talked about this, log base bx equals y is the same exact thing as x equals b to y. So that's stuff we've talked about. Okay, moving right along. So we do have some strategies when it comes to solving log functions. You definitely want to use this property, which I just wrote about a few seconds ago. You definitely want to use that. Also, you may want to consider using the product property, which was from section 3.3. Looks just like this. Quotient property, which looks like this. And the power property, which is this right here. So that's all stuff we've done in section 3.3. All section 3.3. And this we learned about section 3.2. So if you see multiple logs, you're going to use either 2, 3, or 4. You see multiple logs, because you're going to want to condense. And for this one over here, this allows us to rewrite the equation. And you'll want to isolate the log first. So in this case, for example 2, part A. Actually, there's parts B and C, but we'll do part A. Divide by 3. So ln 2x equals 4. Remember, ln is log base e. And if I use this first property mentioned here, log base bx equals y is x equals b to the y, so 2x equals e to the 4. And x will be e4 over 2. You can plug in the calculator if you like. I don't really care. but sometimes exact answers might be better. So what I suggest you do is pause the video, work out parts B and C, and we'll see if we get the same answer. Okay, I'm going to work them out. Hopefully pause the video. You just get 12. But here I can divide by 4. Log base e of 3x equals 2. 3x equals e squared. X is e squared over 3. So that works out very nicely for us. Okay, now we get to some log equations that are a little more involved, where you see multiple logs. So you want to use properties 2, 3, and or 4 from the previous page. On the previous page, just right here, so 2, 3, 4. We use a combination of these, or maybe just one of them. So if I see 2 logs being added, I'm going to condense it as a product, just like that. And by the way, if you don't see a base, hopefully you recognize that's base 10's common log. So x times x minus 3 equals 10 to the 1 power. So what I did was I used the product property here, and then I rewrote the log equation, which is using the first property on the previous page, log base bx equals y, the same thing as x equals b to the y, something we talked about in section 3.2. So then we can distribute and move the 10 back to the other side, factor it, should be pretty comfortable with. They get 2 answers, 5 or negative 2. Now, however, you do need to check your work. The reason why is you can't take the log of negative numbers. So 5 is okay. You just got log 5 plus log 2 equals 1, it's log 10 equals 1, that checks off. But the problem is that if you plug in negative 2, you have log negative 2 plus log negative 5 equals 1. Here's the dilemma. Yes, you can multiply these two and get log 10, but the problem is that individually, log base 10 of negative 2, log base 10 of negative 2 equals something? That's crazy. I can't take 10 and raise it to some power and make it negative 2. You can't take a positive number and multiply it over and over again and make it negative. You multiply positive numbers, they say positive. So the negative 2 is no good for us. The 5 is okay. So you need to make sure you're not logging negative numbers. So you can't log negative numbers or even 0. Only log positive numbers. So go ahead and try part D on your own. Then we'll do one word problem and we're done with the video. Okay, so let's go part D. So hopefully you recognize that you are going to multiply x plus 5 with x. So you condense the log. Then you shift it, you rewrite the log equation. And simultaneously I'm going to distribute the x into x plus 5. 6 squared hopefully realizes 36. Bring it over to the other side. Factor, we factor like that. And we get 2 answers, negative 9 or 4. Now, negative 9 is not okay because it makes that negative, it makes that negative. So you can't log negative numbers. Your answer could be negative if you plug it back in, it comes out clean and you're logging a positive number, but nope, we can't do negative 9, we want to do 4. Okay, now we're going to do a word problem. We'll do a lot of word problems like a 3.5. Now in this case, what you're going to want to do is recognize the formula here. Again, the formulas I give to you, you don't have to memorize them. Here we go. You might remember the interest compounding formula. And remember that this is our A value because we want our money to grow to $500,000. P is what we start with. We start with 25,000. R is our interest rate, but it's a decimal, so it's 0.09. And compound monthly means N is going to be 12, because you're doing it monthly. So I plug all this stuff into my formula. 500,000 equals 25,000. 1 plus 0.09 divided by 12 raised to the 12t power. And we did do this in section, I think, 3.1 or 3.2, where you wanted to graph each side. Like, you remember we let one side be y1, that was y1, that was y2, and we see it already touched. So you can use that to check your work, but you would have to make an adjustment to your window as well. Or we do a little algebra here. Divide both sides by 25,000. So we're going to isolate the power. So we get 20 equals, and use a calculator. I do have this memorized. I don't know why I still have this memorized, but if you were to work out 1 plus 0.09 divided by 12, you get 1.075 raised to the 12t. And you're going to rewrite as a log. So log of 1.0075 of 20 equals 12t. So you will need to use a calculator for this. Hope you remember how to do that in the calculator, alpha, window. So you will need a graphic calculator for this, or scientific calculator at the very least. Or I guess you can use the Desmo scientific version. But if I do 1.0075 of 20 and divide that by 12, I should get, oops, let me try that again. Yeah, divide that by 12, you should get about 33.4 years. So if you were to invest this money into an account that pays 9% interest, which is really good, by the way, usually the S&P 500, one of the stock indices, sorry, using proper grammar, tends to grow about 5-6% a year since the Great Depression. Of course, we had an economic downturn in 2009, but that's neither here or there. So yeah, if you're like in your mid-20s and fresh in the workforce and you got $25,000 to invest, smart to do that because your money will grow pretty nicely when you're ready to retire. Of course, you should always contribute too, but again, this is not econ. So that concludes this video.